Good morning, class. This is Mr. Eggleston, and this is lesson 7.7, solving quadratics or quadratic equations using the zero product property. Basically, the zero product property states the following. 0 times 20 equals 0. 0 times 2 billion, imagine that's 2 billion, equals 0. 0 or negative 20 times 0 equals 0. And let's go with variables. X plus 2 times 0 equals 0. Basically, 0 times pretty much any number is equal to 0. And that's the zero product property. So great, let's see how we can actually use this. All right, so going here. Yesterday we learned how to write quadratics in intercept form by finding its factors. Today we'll explore how using factor form can help us solve quadratic equations. So the first question is just to graph f of x equals x minus 2 times x plus 3 using Desmos. Desmos is right here. And I graphed it right there. And you can see we can use this to help us graph. We can see where the x-intercepts are, negative 3 and 2. And also we have the vertex down there at negative 0.5 comma negative 6.25. So it's at negative 3 and 2. And it's at negative 0.5, negative 6.25, which puts us roughly down here. And we have our, and we have our parabola. And it looks something like that. It looks horrible, I know. And we'll see how we can do it a little bit nicer. What is the x-intercept of the graph of f, or y-intercept of the graph of f? Well, y-intercepts always, and I do mean always, occur when x equals 0. So plug in 0 for x. F of 0 equals negative 2, because 0 minus 2 is negative 2, times positive 3, which equals negative 6. And there's negative 6 right there. How do you know? Because f of 0, which equals negative 6, is defined as the y-intercept. Okay? What are the x-intercepts of the graph? Well, according to Desmos, they're at x equals negative 3 and x equals 2. When is the function f of x itself, not the graph, not looking at the graph, but f of x equal to 0? Well, f of x equals 0 at x equals 2, because if you put 2 into this, you get 2 minus 2 is 0, and 0 times 2 plus 3 is 5. 0 times 5 equals 0. So x equals 2, and x equals negative 3. Because if we put negative 3 into this, we had negative 3 minus 2 is negative 5. Negative 3 plus 3 times 0. That also equals 0. Okay? So there you go. How do the intercepts relate to the equation? The x-intercepts that is x equals 2 and x equals negative 3 make f of x equal to 0. And that is exactly what is said there. Okay. So now let g of x equal x minus 1 times x minus 4. Without graphing, determine the y-intercept of the graph. Well, like I was saying earlier, that's f of 0, which is negative 1. 0 minus 1 is negative 1. 0 minus 4 is negative 4, which is 4. Okay, what determine the y-intercept? So the y-intercept equals 4. Without graphing, determine the x-intercepts. Well, the x-intercepts occur when each factor, the x minus 1 and the x minus 4, are set equal to 0 independently. Okay, so we do this. We set each one equal to 0 and solve. One side gives us x equals 1, the other one gives us x equals 4. So they're at 1 comma, well, no. The x-intercepts are x equals 1 and x equals 4. Let me just scooch this over. There. When is g of x equal to 0, the function? G of x equals 0 at g of 1, which gives us 0 times negative 3, which is 0, and g of 4, which equals 3 times 0, which equals 0. Okay. Check your work by graphing the function in Desmos. X minus 1, x minus 4. Come on. Where's my Desmos? X minus 1, x minus 4. And there it is. Okay. Notice the x-intercepts. I hope it was x minus 4, x minus 1. Okay. Yep. Okay. So they concurred. All right. So what is the relationship between the factor form of a quadratic equation, the x-intercepts, and the values at which the function is equal to 0? Okay. The factored form gives us the roots, gives us the zeros. Of the function. Because we set each factor equal to 0 and solve. Now, we'll explore this relationship further with some number puzzles. I'm thinking of two numbers that multiply to 24. Well, there's a bunch of numbers that can work. You can have 2 and 12. You can have 4 and 6. You can have 3 and 8. Or you can have the negatives of them, too, the opposites, because those are positive 24. These are positive, and so forth. You can also have 1 times 24. Okay, so these are the possible choices. I'm thinking two numbers that multiply to 15. Well, 15 is 1 times 15, which equals 15, and 3 times 5, which equals 15. Still, we have a couple answers. Now, look at what the difference is. Now I'm thinking of two numbers that multiply to 0. Well, you can have 3 times 0 equals 0. 0 times negative 200 equals 0. 0 times x plus 3 inside parentheses equals 0. It could be, there's an infinite number. Infinite combinations. Just need one number equal to 0. And that wipes everything out. Here are a few more puzzles. 7 times heart would make, what values of heart would make 7 times heart equal to 0? Well, heart would have to be 0. What values of A would make A times negative 3.25 equal to 0? Well, that would just be A equals 0. What values of heart would make 0 times heart equal to 0? Heart would be 0. Actually, it could be 0. It could be 1, 2. It could be negative 30,000. Right? It can be any number, because 0 times any number is 0. What values of A would make 100 times 5 minus A equal to 0? Well, we have to figure out what makes 5 minus A equal to 0. So we solve that. We say, okay, 5 minus A equals 0. A equals 5. What values of X would make X minus 9 times 23 equal to 0? Well, that would just be X equals 9. All right, you basically set X minus 9 equal to 0 and solve by adding 9 to both sides. What values of X would make X minus 4 times X plus 2 equal to 0? Well, we get 2. X minus 4 equal to 0. X plus 2 equal to 0. That's going to give us X equals 4 and X equals negative 2. Okay? So you see, to find the zeros of a function, we just set each factor equal to 0 and solve in the equation. So what values of X would make X plus 5, X plus 3 equal to 0? X equals negative 5. And set X plus 3 equal to 0. X equals negative 3. Find the x-intercepts of X plus 5, X plus 3 using Desmos. So here we go. That is X minus 3, X plus 5. All right, just to verify that that's correct. X plus 5, X minus 3. I'm a little dyslexic, but it doesn't matter. So here's the graph. Oh, I forgot I locked it. There's the graph. Okay. Notice, has x-intercepts at 3, 0 and negative 5, 0, just like we predicted. Okay, so this is at x equals negative 3 and x equals negative 5. All right, so what values of x would make x squared plus 8x plus 15 equal to 0? First thing we got to do is factor. What multiplies to 15 adds up to 8? And you could say that that's going to be 3 and 5. So that's going to be x plus 3 times x plus 5. And we want to know, when does that equal 0? Well, that equals 0 when x plus 3 equals 0, which is x equals negative 3. Or that equals 0 when x plus 5 equals 0, which gives us x equals negative 5. So the zeros, x, would be x equals negative 3. Oops, sorry, I wrote x twice. So this is x can equal negative 3, and x can equal negative 5. But the first step was to factor. Find the x-intercepts of x squared minus 3x minus 10. Well, we're factoring, so what multiplies to negative 10 adds up to negative 3. That's going to be negative 5 and 2. So we can rewrite this as x minus 5 times x plus 2 equal to 0. Set each factor equal to 0 and solve. That gives you x equals 5. Set x plus 2 equal to 0 and solve. X equals negative 2. And that's the two answers. All right? So, some of the margin notes. Okay? A product is 0. That's what we got from question 5. If only one of the factors is 0. It doesn't have to be both, just one of the factors is 0. Okay? When we're doing this, when is 5 minus a equal to 0? When is this equal to 0? Because 100 times 0 gives you 0. And when is x minus 9 equal to 0? That's when x equals 9. All right? Notice when we had this, since we have 0 on the right, this is the only reason we can do this by factoring is because we have 0. Set each factor equal to 0. X minus 4 equals 0. X equals 4. X plus 2 equals 0. X equals negative 2. Okay. So there are two solutions. Here's another one. X plus 5 times x plus 3 equal to 0. Well, one side will give you x equals negative 5. The other one gives you x equals negative 3. There are two solutions. Find the x-intercepts of f of x equaling x plus 5 times x plus 3. Well, it's the same numbers. X equals negative 3 and x equals negative 5. The solutions to f of x equal to 0 are the x-intercepts of f of x. That's key. To find the x-intercepts of f of x, we have to find the zeros of the function, because remember, the y value of the function, where it sits on the y, up and down vertically, is equal to the y values. It's the y. So when y is 0, that's the x-intercept. Okay? So they are the same. So when they give you one like this, first you have to factor the quadratic. And that's what I did here. And we got x equals negative 3 and x equals negative 5. Same thing with this. We factored it. X equals 5 and x equals negative 2. Okay, so the solutions to f of x equal to 0 are the x-intercepts. That's the key, that's the money shot right there. Are the x-intercepts. It's where the graph crosses the x-axis of f of x, where the output, the y value, is 0. If a quadratic in factor form is equal to 0, then one of the factors must be 0. Solve for the x value that makes each factor equal to 0. And lastly, to solve a quadratic in standard form, factor it if possible, then determine when each factor is equal to 0. All right, there you go. I hope that was good, and I'll come back with the CYU.